Hello everyone. Today we're going to start talking about electricity. In this section we're going to talk about electric charge and static electricity. You're already late for school and one of your socks is missing. You finally find it sticking to the back of your blanket. How did that happen? The explanation has to do with electric charges. Types of charge. Atoms contain charged particles called electrons and protons. If two electrons come close together, they push each other apart. In other words, they repel each other. Two protons behave the same way. If a proton and an electron come together, they attract one another. Protons attract electrons because the two have opposite charges. A charge on a proton is positive. The charge on an electron is negative. So like charges repel each other, and different charges attract each other. Two types of electric charges interact in specific ways. As you see in figure 1, charges that are the same repel each other. Charges that are different attract each other. Like charges repel, opposite charges attract. The interaction between electric charges is called electricity. The force between charged objects is called electric force. Electric fields. You may have heard of a gravitational field, which is a space around an object, such as a planet, where the object's gravitational force is exerted. Similarly, an electric field extends around a charged particle. An electric field is a region around a charged object where the object's electric force is exerted on other charged objects. Electric fields and forces get weaker the farther apart they are from the charge. Let me say that again. Electric fields and forces get weaker the farther away they are from the charge. An electric field is invisible. You can see the field lines to represent it shown in figure 2, which is this right here. A field line shows the force that would be exerted on a positive charge at any point along that line. Positive charges are repelled by positive charges and attracted to negative charges. So the field lines point away from positive charges and toward negative charges. Single charges that have straight field lines sense a positive charge will be repelled away from or attracted to it in a straight line. When multiple charges are present, each charge exerts a force. These forces combine to make more complicated field lines. So as you see here, if you have charges going out or inward based on the attraction or repelling of each other. How does a charge build up? Most objects have no overall charge. Usually an atom has many electrons as it does protons. So in other words, the number of protons is equal to the number of electrons. So each positive charge is balanced by a negative charge. So if you have 5 positive charges, it is also going to have 5 negative charges, which makes the overall charge 0 or neutral. This leaves the atom uncharged or neutral. An uncharged object can become charged by gaining or losing electrons. If an object loses electrons, it is left with more protons than electrons. It has an overall positive charge. If an object gains electrons, it will have an overall negative charge. The buildup of charges on an object is called static electricity. In static electricity, charges build up on an object, but they do not flow continuously. Here's an example. A balloon is positively, negatively not charged. The balloon attracts, repels, neither attracts nor repels the girl's hair. Well, if we look here, there is an equal number of positive and negative charges, 3 for each. So the balloon is neutral or not charged, so the balloon will neither repel or attract the girl's hair. If you take that same balloon and you rub it against your sweater, this increases the number of electrons that move onto the balloon. Now the balloon has more negative charges than positive charges. So the balloon now is negatively charged, and as a result, it will attract this girl's hair. Now, the reason being, specifically, the balloon is attracting the positive charges in the girl's hair. Remember, like charges repel, unlike or different charges attract. So again, the negative charge in the balloon is attracting the positive charge in the girl's hair. Charging objects. Charges are neither created nor destroyed. This is the rule known as the law of conservation of charge. An object can't become charged by destroying or creating its own electrons. If one object loses electrons, another object must pick them up. There are 4 methods by which charges can redistribute themselves to build up static electricity. Redistribute means move. These are by friction, conduction, induction, and polarization. Let's talk about friction. When charging by friction, when 2 uncharged objects are rubbed together, some electrons from one object can move on to the other object. The object gains electrons and it becomes negatively charged. The object that loses electrons becomes positively charged. Charging by friction is a transfer of electrons from one uncharged object to another by rubbing objects together. Charging by conduction. When a charged object touches another object, electrons can be transferred. Charging by conduction is the transfer of electrons from one object to another by direct contact. Electrons transfer from the object that has more negative charges to the object that has more positive charge. A positively charged object, like a metal ball, gains electrons when an uncharged person touches it. The girl starts out neutral, but electrons move from her hair through her arm to the ball. This leaves her hair positively charged and the strands repel each other. That'd be this illustration right here. I'll read this to you again. A positively charged object, like the metal ball, see the positive charges, gains electrons when an uncharged person touches it. The girl starts out neutral, but the electrons move from her hair through her arm to the ball. This leaves her hair positively charged. See that there? And the strands repel each other. Strands of her hair to be exact. Charging by induction and by polarization. Electrons can react to the electric field of a charged object without touching the object itself. In some materials, like metals, electrons can easily leave their atoms. When a metal object is close to a negatively charged object, electrons are repelled by the field and move away from it. The closed end of the metal object becomes positively charged. See this here. Again, the closed end of the metal object becomes positively charged and the far end becomes negatively charged. The opposite happens if the other object is positively charged. This process is called induction. In other materials, like the bits of paper in this photo, electrons move only within their atoms. The electrons react to electric fields, resulting in individual atoms having charged ends that are attracted to charged objects. This is called polarization. Charges don't transfer between objects in polarization or induction, so neither method changes the overall charge of objects. Parts of objects end up charged on opposite ends. Let's talk about static discharge. If your hair becomes charged and sticks up after you remove a sweater, it doesn't stay that way forever. Positively charged objects gradually gain electrons from the air. Negatively charged objects gradually lose electrons to the air. The objects eventually become neutral again. The loss of static electricity as electric charges transfer from one object to another is called static discharge. Static discharge often produces a spark. Moving electrons can heat the air around their path until it glows. The glowing air is the spark you see. The tiny spark you may have felt or seen when near a doorknob is an example of static discharge. Sparks from discharge happen more frequently during the winter. This is because objects hold on to charge better in dry air. In humid weather, water collects on the surfaces of objects. The water picks up the charge from the objects so they don't stay charged as long as they would in dry weather. This is why in the winter months and the fall months and towards the spring, when you get out to get gasoline, it's always a good idea to, before you go and pull the pump, touch your car so that any charges can be removed and those charges don't spark and accidentally ignite gasoline. So it's always a good idea to touch your car when you get out to pump gas before you start that process. Lightning bolts are an example of static discharge. During thunderstorms, air swirls violently. Water droplets within the clouds become charged. Electrons move from areas of negative charge to areas of positive charge, producing an intense spark. That spark is lightning. Some lightning reaches Earth. Negative charges at the bottoms of storm clouds create an electric field. This causes Earth's surface to become positively charged through induction. Electrons jump between the clouds and the Earth's surface, producing a giant spark of lightning as they travel through the air. This concludes our reading for the introduction of electricity. Thank you. Goodbye.